Hello guys, today edition. Uh, this is a my 220-volt generator, induction generator. So if you look at here, this is the casing I fabricated for the generator. So I use a damper. I use a Tiger generator damper. So see, so let's start. You can see this is a gasoline generator induction, but I have I have modified it. I have modified it. So I want to demonstrate that this induction generator can be run with a brush. This is a generator armature. I modified the armature with a commutator. Modify it. So you can see there is no need in making use of a capacitor with this generator. So there is no need in using capacitor on this generator. You can use brush. You can apply voltage, converting induction generator like brushless generator to a brush generator. I use this commutator. So let me lose this generator. Like gently. So this is the back cover. So let me lose the armature. This is the center load. Let me apply it softly. Now this is the armature. This is the starter coil. This is the starter coil. You can see. So this line here is for capacitor. Is for capacitor. While this one is for 220-volt output. So now you can see this rotor or this armature. You can see it. So that's exactly like this. Just that I remove the fan. I remove this fan. So I just this brush is for 2900 fireman generator. So you can see how I fabricate. So I just dismantle this diode in there, then connect it. And when you want to make sure that it tallies with this, assuming this is not, so that when you apply your power, so that this side will also be not side, so to avoid reduction in voltage production. So that is it. So this is how I do it. But concerning this armature, I the positive goes to the brush, while the negative is the whole shaft. So you can see the wire here. I just attach it on the body of this iron. So the negative, the whole armature, the whole rotor is negative. While this particular here is brush. You can see the wire. You can see the terminal here. You can see it. So I convert the brush less generator to brush generator, so you can see how it works. So this is the casing, the cover. You can see here. So you can see here. So now I I use a brush. I use a brush. You can see this fireman alternator brush. You can see. So it has a two brush, which means two terminal. So you can see it. Now, but my own, I just remove one terminal. I just cut it off because there is no need, since my armature is, the body is a negative while the is positive only. So now to see how I make it. So here is red, which is positive, while the body, entire body is negative. You can see how I make it. So there is no need of connecting it. I will just dismantle it. So now just watch so that you see how I do it. So bring this thing out. So I have to press this thing now on the this knot. I have to tighten it. You can see. Now let me put this armature. You can see it has a direct contact. You can see. You see it has a direct contact with the brush, with the commutator. I mean, yeah, it has a direct contact. So that is it. That is how I do it. Okay. Let me put my starter coil. Sorry, I have to connect it first. Make sure that the coil sits well. That the coil sits well. You can see the brush has gone inside. So let me put this armature. Let me put this rotor. Now I have put it. Okay. Let me put the center rod. Let me tight it. Make sure that it fits so that there will be, it won't pull out. So due to this armature, the bearing is a big bearing, so this one is a small bearing. So because of that, this casing won't be used. So I have to use another casing, small city casing. So this I'm sure I have to remove it. So let me connect this one. So make sure that everything is perfect. So this thing is the shaft is rotating free, so which means that the alignment is okay. So let me tight. Okay, now we have brush generator. So so this is the brush generator now. So this is the city now where we keep the generator. So uh, generator have seat firm. So you can see it. So you can see. So now let me connect the motor. The motor. Now you can see. This is where I file. So it will be on the top. No, it's not going inside. So now let me tight it. So let me even tight the motor so that it will sit firm. So now what I have here is a brush generator instead of brush and using capacitor. So let me turn it around. Okay, this is the output wire. Remember, like I say that the frame of this system is negative, while this red wire is a positive only. So take note. For simplicity, that's why I do that, for simplicity. So now I have to test it to see how it work. So let me, I haven't locked this place, so the generator is very small. So this is how I lock my, you can see it. Okay, now this is a 9 volts battery. So now let me check it with my meter. You can see 9.6 volts. Okay, let me switch it to AC again. So now I have to connect my meter. Let me put it to see if there is any display of voltage. Let me use my hand to rotate it. There's no anything. Let me put it at 200. Okay, so now let me put it at, let's see, 700 maximum. So now this is my positive from the brush. You can see the brush attaching the commutator. Now let me connect it on the positive. Then the frame of this generator is negative. You can see. Okay, let me put it at the lower voltage. So you can see there is a signal. So let me connect. This is the, remember the brush from this wire is positive. So this is the positive of the terminal. Remember this is 9 volts. So let me, the body of the generator, the system is negative. So I use my applying it up. Connect the LED. So let me rotate this shaft to know if there will be output. Okay, 4 volts, 6 volts. Okay, let me connect this 12 volts to the same. Let me see what it will give me. So I've put it, and let me connect. So you can see there it is even reading. There is a reading there. I've connected it. Okay, 13 points, 13 volts. You can see 21. Wow. So this is brush generator. You can see there is a reading. So you have seen what I demonstrate, that I can convert brush generator to brushless. So by applying commutator and putting a brush, So now I have to run it. I have to run it. Then I have to apply this 9 volts, and I have to apply 12 volts and 24 volts. Let me see what it will give me. And again, this is my step down model. Model. It is I think 400 watts. You can step from 40 volt down, so you can use it. So the reason why I want to use this is so that I will the will be increasing the voltage input here, so that it will determine the voltage output here. First of all, I have to test it with this 9 volts when the motor is running. So I have to apply 12 volts here in the input, I mean 24 volts here, then control it with the output, so that I will know once I apply 12 volts here, how many voltage will this generator give me. And once I apply 24 volt, when I increase it with increasing this, you can see increasing the potentiometer here, we allow the voltage to increase, which will give more output from this generator. So I have to, first of all, when I start the generator, I have to apply 12 volts. So when I apply 12 volts to this motor, when the motor is running, I have to first of all test it with 9 volts to know how many voltage the generator will give me. And I have to use this potentiometer, I mean this step down model, and apply it to a 424 volt to see how many voltage the generator will give me. So okay, now I have another meter, so that I will use it to determine the the input, while this one will read for output, this one will read for input. So now I have another source, so let me test it to know how many voltage. Okay, it is 25 volts DC. So now that 25 volt DC, I have to apply it to the input. You can see N input. The maximum voltage of this module is 40 volts. So I have to apply the input here. Input voltage here. This is the positive. So when putting it, so to avoid damaging the module, let me tight it. Then let me apply the negative. You can see it does not bring light. So no, now the output will be determined when you shift the potentiometer. So now let me check it. This is the output. Let me connect the meter. So the output is 9 volts. Okay. So now I want to run this motor, this generator, so that let me see. You can see. Let me connect the output. Let me connect the output. Now I have connected the system. So the motor is going to start running. So I have connected the motor now. You can see 2 volts. So now let me connect this battery. Remember, this battery is 9 volts. Let me connect it. Okay, 7 volts AC. You see 7 volts AC. Oh, so now let me disconnect it again. Okay, I have some issue with this element, but it is now okay. So now this is the positive terminal from the brush. So now how to check it now. This is the output positive. So I have to lose this, yes man. Then let me type it. So this the body, remember the body of this generator is negative. So let me lose it now. Oh, this is back EMF. So I've already connected it. Let me switch this motor off. And another thing again is I want to connect my meter to the same terminal so that it will enable me to know the amount of voltage that I'm putting on this lotto. So both are connected. The terminal of this meter is connected. So now let me switch it on. You can see the on and off switch here. I'll switch it on. So it is 13 volts. Remember the input is 25. So let me switch it off again. I'll switch it off. Also, I'll switch it off again. So now you can watch the the meter terminal is disconnected already. I got more than I made a mistake because I don't know that the meter terminal is dismantled. Maybe later we still check it with this 7 volts. I mean 9 volts. But I don't know that the meter terminal is because before it give us 7 volts, which is supposed to give more than that. Okay, now let me connect my DC motor back. Remember, I off this system. I off it. So now the motor has now rolling. Let me on it back again. Okay, 150 volts, 13 volts. So 13 volts going to the brush give us 160 volts output. I don't know if you are following me up. This meter is from the input. So now I will determine the voltage of this generator by regulating this. So now let me regulate now. Let me regulate now the voltage. Let me bring it down. I'm bringing the voltage down. I'm bringing it down. I'm bringing it down. I'm bringing it down. You can see? I'm bringing it down. I'm bringing it down. So now the input is 7.5 volts. Then the generator is giving me output 5 volts. Now okay, now let me increase it again once and for all. I'm increasing it. I'm increasing it. I'm increasing it. You can see? I'm increasing it. So imagine 17 volts will give us 220. Understand? Can you see it? So increasing it more because the input is 25 volts from this side, but I'm determining the speed, determining the voltage by regulating this. So the here now the meter is reading from here now. So it is 17 volts from 17 volt now. So this gives us 220 now. So there is no need of using capacitor on this system now. So this is the brush. So now I can determine the voltage output from regulating. So the reason why I use this model is that once you leave it at this 17 volt for 17 volt plus 5, that is the range it will stay. It won't go beyond that. It won't reduce unless will reduce from here. So that is it now. I have now converted brush generator to brushless. I'm now converted to a brushless generator to brush. So there's no need of using this capacitor again. There's no need of using the capacitor again. So you guys can see how it works. Now I think I will put a load here. I have to put some load here. Which show there is a output, and this is not even shaking the output. That's why this is very a good model. So that is it. So this is a wonderful setup. So you can see, to show here, you see the brush is having a contact. Having a contact. Having a contact. You see the you can see very well. So so let me connect this bulb, this 60-watt bulb. Let me connect it. Let me connect it. Okay. So I've connected this. So the voltage has dropped now. It is 17.5 volts. So if I want to determine the speed now, the voltage now to be 220 now, I have to adjust here now. You see, from the brushless to brush, from induction to brush. So the benefit of using this is that you can determine the voltage by regulating the this. Remember the input is 25 volts. So regulating brushless. So you guys can see I'll convert brushless generator to brush. Before I'm having a misalignment, so that's why because this shaft is cracking on the body of the motor. So, but now it's worked better. So it's the issue of misalignment, but now it has worked better. So so the voltage is stable, everything is stable, 17.5. So the voltage of this will be dropping little by little because the voltage, the battery, there's no energy regaining. So it can be dropping. You'll be noticing it on the output voltage because of the speed reduction. But this is stable because this module is very stable and monitoring the voltage. So there's no increase because if this fluctuates, if this goes down up, it will affect you get the effect from this output. But this input is stable. So that's why the voltage is stable and everything is stable. So so my aim to demonstrate this to show you that converting brushless, which is induction generator, can be done this way. It is possible. So remember the coil, this is the capacitor line. This is the capacitor. So I can easily achieve it by converting it to brush again by connecting diode in the output, then brush, connect capacitor here. So, but induction generator monitoring the output is very complicated, but this one is very easy, whereby adjusting. So now, if I want this voltage to goes down now, if I want it to goes down, now let me decrease it. Let me by adjusting the inputs. Then the voltage will go down. I'm decreasing the speed now. I'm decreasing the voltage now. You can see the voltage is going down. I'm shifting it anti-clockwise. The voltage is going down. The voltage is going down. You can see 10 volts input. The bulb is going down. 117, 18 volts input, 19 volts. Okay, now I can watch. 6 volt input, 60 volts, almost 60 something volts output. So the voltage on the bulb is very down. So 4.8 volts input give us 58 volts AC output from the generator AC output. Then 3.54 volts give us 41 volts output. Then 2.5 volts give us 1 volt AC output. Then 1.7 volts give us 23 volts AC. 1.4 volts give us 20 volts. So now if I started increasing it now, that's how the voltage will be counting up. And I'm increasing it now. You can see the voltage is going up now. The voltage is going up now. It's going up. The bulb now starts shining. So you can see. Oh, the bulb has been really disconnected. Uh-huh. So you can see those road give us 150. Let me set it back at the spot again. 14 points. 1 minute. The bulb has been disconnected. So I have displayed which name so it is possible converting brush generator to brush generator. Thank you for watching.